Pete Murray of CCI Systems. Pete has been around the industry for a long time and knows all about DAS. He was with MCI in the early days, level 3. I don't have his bio, I can't find it. But anyway, Pete Murray has been instrumental in the DAS forum, both on in-building committee and market development. And he's going to lead you through a variety of issues that regard Wi-Fi and DAS and what part it plays in the network, and our panelists have some different views on it, so it'll be fun to watch. Thank you. Thank you, Pete.
Good afternoon, everyone. I hope you're enjoying your lunch. For the next hour and 10 minutes or so, we're going to go cover the issues surrounding Wi-Fi and DAS. A little later on, thank you.
That by 2015, there'll be more than 200 million smartphones operating in the US. And the compound annual growth rate is about 67% between 2010 and 2015. Huge surge. And we believe this transformation in terms of the devices that people are using and the expectations on the part of users are driving the convergence of Wi-Fi and DAS. And they're also changing the way that you need to look at network implementation. So instead of basic connectivity to a device like a cell phone, you now have to look at bandwidth management and bandwidth preservation. It's even more important to look at application management and securing the enterprise and the user from inappropriate applications or abused applications. It's also essential that we handle what's called BYOD, bring your own device to work, where you go to a stadium, for example, and all of a sudden there are 30,000 devices that appear on your network. What does that mean, and what opportunities does that present for you? At the Australian Open, they've decided to take those devices and to monetize them. So in exchange for free internet access in that stadium, 30,000 users got 1.5 million McDonald's and Coca-Cola impressions, and the funds that came from the advertisers offset the cost of the network. Nobody would have thought of doing that before, but there are all kinds of ways that you can take advantage of this change in mobile computing, not only to improve network performance, but also to monetize the system. So the change in devices, the change in user habits are also driving expectations on the part of users. Somebody said earlier, about young kids getting on an airplane and saying, how come my iPod Touch isn't working here? Where's the Wi-Fi? There's a whole generation that has never touched an Ethernet cable before because the devices that they use don't accept Ethernet cables. They expect Wi-Fi, they expect ubiquitous access. Presents a huge challenge for an IT organization. In the past, you used to have this beautiful, pristine, clean, firewall-protected, IT-managed network. And then the first person who comes in happens to be the CEO with an iPad or an iPod that they got, or an iPad that they got for a birthday present, and said, forget all that security, I want this device to work on this managed network. What do you do? How do you handle that? So these are some of the challenges that are coming today. In addition, we have security issues that have profound implications for both IT managers and for end users alike. There are so many vehicles now in which security can be broken in these networks that it's very important not just to look at basic connectivity, but how can we manage these networks in order to protect the devices without interfering with open use of the networks. Multimedia applications have fundamentally broken a lot of networks over the last 5 years. In the IT space and in-building systems, a device that can change from video chat to voice to data breaks the traditional IT infrastructure of using VLANs, for example, for quality of service. The next generation of indoor networking actually has to look at what applications are being used and assign quality of service automatically to that. And it needs to carry that forward when those applications are offloaded from the cellular network to the Wi-Fi network. So there has to be a lot more integration moving forward during that handoff process from cellular to Wi-Fi and back. Again, these are challenges we're just now starting to face. The fourth area has to do with the way in which people are using their networks. IDC reports that on the order of 40.7% of all of the business applications that are accessed in the US are accessed with user-owned smartphones versus an employee-provided, managed, controlled device. That means that intellectual property is now at stake because it's very easy to go in and grab a spreadsheet or grab a source code and push it out through box.com in a way that was never possible before with a managed device. So we're seeing these huge changes coming, and they're only going to get worse because this BYOD phenomenon, bring your own device to work, means that we have to have pervasive networking. It has to be secure everywhere, and it has to handle this huge surge in devices with mixed operating systems and applications that users select. They're not selected for them. Big challenges ahead. So what does this mean for all of us? For one thing, it means that as you look at a network moving forward, you can't assess it on the basis of the connectivity you provide, but rather how the user is going to use that particular network. Multimedia is driving demand through the roof, so offloading is going to be a requirement. It's going to be essential, but you also need to make sure that whatever you're offloading to has the capacity to handle it. Somebody else asked a question this morning about Wi-Fi in this hotel. How come it wasn't able to handle the traffic? Well, my answer to that is that it wasn't designed properly, because it should be able to handle it. You expect to have conventions. You expect to have a full hotel. Why isn't it handling it? Well, it might have been an older generation. So you need to consider how many users you're going to have on your network when you put the design in and accommodate it. So as I mentioned before, this convergence of devices into smart mobile systems that cut across the line between cellular and computing platforms is driving the integration of Wi-Fi and DAS together. And there's several reasons behind this. The first is that since users now expect to have ubiquitous coverage, that means that Wi-Fi and cellular and DAS also have to have the same coverage area. So if you're going to be covering the same area with Wi-Fi and cellular, doesn't it make sense to integrate the two together at the time of installation? There are a lot of savings that can result when the two cable systems are pulled at the same time. There's one throat to choke during the integration of the system. If you're doing a neutral host system, you can set up the Wi-Fi offloading across multiple carriers at the same time. It's a very compelling case. The thing is, not all DAS are created equal. Now, I look at this again from the perspective of a Wi-Fi vendor, not a DAS vendor. From our perspective, it is criminal to think about taking 802.11n Wi-Fi and pushing it out through a DAS system and remoting the antennas. It breaks all of the technology that we've developed in the last 5 years within Wi-Fi to do it. It breaks our MIMO, it breaks our adaptive radio management, it breaks our ability to location and triangulate users. So if you're going to integrate Wi-Fi into DAS, it should be on an active DAS network where the Wi-Fi access points are located exactly where they were designed to be used, which is locally where they're going to be used by users. And you should use the DAS for Ethernet backhaul. Basically look at it as a big switch, taking Ethernet taps off of the DAS and plugging the Wi-Fi access points into those sites where it's appropriate. Passive DAS cannot do that. You should never, ever run 802.11n over a passive DAS. Cisco says it, Aruba says it. We're the two largest Wi-Fi vendors. I'm sure the smaller vendors also would say that to you as well, because it breaks those systems fundamentally. If you look at hybrid DAS, it lacks the capacity that active DAS has. So from our perspective, if you're going to merge the two, you should use an active DAS solution, and you should design the system as a backbone, Ethernet backbone, and let the Wi-Fi vendors put their devices where they're intended to be put, and locate the remote antenna units where they're intended to be used. This is a diagram showing both indoor and outdoor solutions where we've got Wi-Fi access points connected into distribution units. And for outdoor, you can do the same thing. I'm very happy we're having a tour of Turner Field. Turner Field happens to be one of my company's deployments. Covers the entire field with Wi-Fi, so they can offer sports statistics and so on. So this solution works for both indoor and outdoor DAS solutions. It distributes all of the signals, both whatever DAS would normally do, plus it distributes the Wi-Fi system. And it allows you to have a single contractor install the whole solution. Multiple benefits to this. Active DAS can support multiple carriers simultaneously, so it's great for neutral host. It keeps intact all of the features that the Wi-Fi vendors have labored to put into our products to make them more reliable. It gives better operational visibility in terms of linking the network management solution for DAS with the network management solution for Wi-Fi. So through one single pane of glass, you get visibility into the whole system. And then you can also save money at the same time through common installation. So in Silicon Valley, among the VC venture capital firms, there's a saying that if you're not in the peloton, you're not in the game. If you're not riding in a group, you're missing out on opportunities that arise. We believe that the peloton today consists of active DAS plus Wi-Fi, and that if you're looking at accommodating user expectations in terms of multimedia access across mobile devices everywhere, indoor, large public venue, outdoor, then this is the right solution to ride. So thank you very much.
Thanks, Mike. Thanks very much. Aruba is doing some really strong things in this space. I've had the opportunity to work with one of your partners as well and understand where you're driving the DAS and the Wi-Fi. You didn't make any shameless plugs, so thank you very much. Just in that vein, thanks to Tracy's beautiful introduction, I might just take a minute to tell you who CCI Systems is. It's not Crown Castle. It's not CCI from North Jersey. We're CCI Systems from Iron Mountain, Michigan. Roughly 400 employees, employee-owned. And our specialty over the years, we're over 50 years old, has been building video networks and internet networks. We build both fiber, DAS, Wi-Fi. We have a very strong relationship in the routing and server industry, and we do a whole lot of head-end work for the cable industry, the TV cable industry. So that's who CCI Systems, Iron Mountain, Michigan. If you see New Jersey with the CCI, that's not us. Okay, so that said, we have a really strong panel here, and I do want to introduce each panelist. So first I'm going to introduce Dennis Burt, and Dennis, I'm not going to read the whole thing, and I'm sure you're okay with that. But Dennis is the Director of DAS Engineering at Boingo Wireless. Boingo is one of the pioneers in the hotspot markets and has obviously been expanding its footprint. And Dennis has been building out DAS networks as part of that team. Next to him, we have Will Smith, not that Will Smith, but Will is the Manager of National Broadband Implementation for T-Mobile, and he's working with the Wi-Fi hotspots and has a very strong knowledge of both the DAS and the Wi-Fi. He's worked with Blockbuster Corporation. He is in the United States Navy Reserve, and he holds a Bachelor of Science degree in Electronic Engineering. That's Will Smith. Next to him, we have Dwayne Baucom, Director of RF Engineering at American Tower. He has been in the commercial wireless industry for over 15 years, and prior to joining American Tower, he spent 8 years with Sprint Nextel, running teams dedicated to FCC rebanding and spectrum traffic analysis. Next to him, we have Nahy Fahmy, Director of Radio Access Network Planning at AT&T. Nahy is his director of that group at Network Planning. His responsibilities include small cell, LTE, UMTS hardware, RF ancillary, and DAS. Nahy holds a PhD in electrical and computer engineering, and he's over 23 years of experience. And Mike, we already introduced. So that said, One of the things that struck me was Mike's first slide. I remember back during the dot-com era, those slides in Wall Street, and one of my favorite analysts, despite his indictment, was Henry Blodgett from Merrill Lynch. Maybe you guys have seen him crop up. Those of you think in a few years. That said, we know that the mobile usage is going to continue to increase, and the devices are going to increase their capability. So my first question is, with LTE and LTE on DAS making its move now, why do we need Wi-Fi to supplement the network? I'd like to ask Connie first, if that's okay.
So, thank you for the question. You can actually ask this question two ways. Some folks will ask the question, if we have LTE, why do we need Wi-Fi? Some other folks will ask the question, as if we have Wi-Fi, why do we need LTE? So I don't think there is, it's a debate anymore between Wi-Fi and LTE or UMTS. I think each one of these technologies have their own sweet spots, have their own applications, and it's not, as I said, it's not a debate anymore as much as everybody is trying to find a way to offer all these capabilities and facilitate seamless transition between them. So if you, moving forward, you're going to start seeing AT&T mainly when we have an enterprise opportunity that we are addressing or a venue that we are addressing, you realize that, again, we just don't go focus on one technology versus others and say, okay, this is our business versus this, as much as try to make all these capabilities available. That's why Turner Field, for example, you're going to find the DAS, you're going to find the Wi-Fi available for our customers to access. If your phone is on Wi-Fi, you have Wi-Fi access. If your phone is on 3G, it's on 3G. If it's on LTE, it's getting access to LTE. So integration of all these technologies and making all these technologies available to the customer is not something in the past. It's something that we need to make available now. What's going to come down the pipe, what's going to come in the near future, if you look at 3GPP release 10 and release 11, is a seamless migration. You don't have to worry about your phone being on 3G or being on 4G or being on Wi-Fi. Wherever you get better experience, this is where you need to be. So you care about your applications, you care about the access, the best RF coverage, is our responsibility to make it available via either Wi-Fi or LTE or 3G. So again, the debate, there is no debate that LTE versus Wi-Fi or vice versa. All these technologies need to be available.
Well, it's sort of the Wild West out there, though, now, trying to keep up with the demand. Here in our venue, right, we recognize that Matt couldn't get his video and play his games upstairs or whatever that one is. I'm sorry, I'm too old. Those things are there. How many people have tremendous cell phone signals in this room right now? Yeah, we're at the DAS in action. When I got off the elevator yesterday, the good news is for the future groups that'll be here, is that AT&T and Connectivity are currently constructing a DAS in the hotel. And when I got off the elevator, I was kind of shocked, like, was this a welcome on 22? There was a guy out with an Andrew box, a couple of antennas that he was sampling, and apparently you're in the benchmark stage right now. We're not in the construction stage. But trying to manage those venues with, obviously, end users that may not understand all the dynamics, what are some of the challenges? Dennis, your company, Boingo, is pretty well sophisticated in both DAS and Wi-Fi. There's a lot of user experience. How do you work those complicated venues like airports and all that?
I would say if I had the answer in a nice, easy format, I'd say this simple, but it really isn't. The challenge is you've got different bands, different services, different not only Wi-Fi, and now with 802.11n, we've We've got 5 gigahertz in the Wi-Fi space to be part of that design. We have capacity issues that we're talking about now. It's changing the way we look at Wi-Fi in a venue in terms of more designing toward a capacity-based solution versus a coverage-based solution. So all these play into essentially a very detailed design process, like what was talked about in the previous session, but that include Wi-Fi as part of that play.
T-Mobile offered voice over Wi-Fi access. Is that still an active product?
Absolutely. In almost all of our phones today.
And what are your experiences as the carrier with this Wi-Fi as an access method?
Well, you really have several different networks in play. We don't tend to think about them, but you have the RF access network from your device to the network, and then you have the transport network, which is the most likely cause of the congestion that we felt last night in our hotel rooms, because it was also on the wired network as well. Dealing with older Wi-Fi networks that were designed for data versus voice, you're experiencing growing pains as more and more smartphones are getting smarter and smarter than we are, and trying to keep up with that race.
Okay, Lonnie, I don't want to get you in trouble, but why does AT&T offer that? Same goes to Verizon and Sprint as well. I'm picking on you.
You know, the old days, there was this debate. Voice, is it better over cellular, or is it better over Wi-Fi? And I agree with Will here. The older generation Wi-Fi APs and technologies were not the best in carrying voice. Let me give you an example. And I mean, this is part of the history. Don't get me wrong. I'm not talking about what's available to us today. We have tried voice over Wi-Fi a few years ago. I can tell you that we stopped looking 10 years ago. And the technology at this time was so shaky to a point where you have your voice active on the device, voice client on the device, and the voice session is active. And somebody walks between you and the Wi-Fi AP, the ball get dropped. So this is where we start Wi-Fi, and I'm sure that there are many Wi-Fi vendors here in the room. Michael next to me can all days the technology between the clients, between the encryption, the encrypting, between the capabilities. This was not the best way of offering voice services. Situation is different today, and all these technologies are technologies we need to be looking at. As a matter of fact, I believe that part of our enterprise Wi-Fi offering today gives the capability to the enterprise customer to carry voice over Wi-Fi, or over IP over Wi-Fi. That's why, and even in small cell, moving forward, our strategy is to make Wi-Fi part of the offer. And customer have a client, they want to do voice over IP over Wi-Fi, fine. So it's the history and the way we saw the technology developing and improving that was not encouraging to us. But nothing prevents us from seeing this today.
Obviously, everything's moving so quickly. We talked about these technologies, and what we talked about in the boardrooms and in the engineering rooms 2 years ago is completely smashed. We have things like Microsoft and Intel that some would say maybe missed. They dominated the PC era, and if the statistics that the Business Insider are putting out that laptops are going to be outsold by smartphones, which is true already, and tablets are going to exceed the sale of PCs, where does that leave vendors that had these markets, but if their market shrinks because of the device change or the change, where do we stand? So when planning these things, Dwayne, I waited for you to sip, by the way. When you plan for these networks, how do you do a timeline? You know where the appropriate is, because as we heard earlier, we don't want to do a forklift upgrade. Yet the things are moving so fast. You know, companies like Instagram, that I've never heard of either, with 30 employees, are bought for $1 billion. Okay, where do we platforms if things are going to change that fast and 30 million people are going to start using a new service within 1 year?
Yeah, well, you know, with the future proofing, and you know, every time you see an RFP or you see like the design requirements are there, they want future proof, right? Specifically, these that always include Wi-Fi, but I mean, the bottom line is no one knows what the reality is coming down the pipe. The exponential of data, obviously, like there have every technology available. You have to have the LTE. You have to have Wi-Fi. No doubt about it. You have to plan for infrastructure, especially where we're seeing most of the growth of that. You have to have the infrastructure there to, you know, and that back to Cat 5 cabling of all sorts, making sure you power these things, PoE. You know, you just have to have those things in place so that you're just not going back, you know, every year and ripping into the walls of these things. But you know, that can only go so far. There's so much you can really do. Everybody would like to future-proof this stuff for 10 years, but that's not the business we're in anymore.
Perspective on that, Will?
Well, the IEEE does an excellent job of constantly seeking new ways to maximize the most out of that little radio spectrum that's unlicensed, right? You got 802.11ac that's just coming out, where it's just going to increase your bandwidth throughput from the client to the access point tremendously. Forklift upgrade, right? Because your current radio won't be able to support that. And that's just the reality. So if you're really looking 2 to 3 years out, that's really as far as you can go.
So Mike, we heard N to AC for those of you that are following Wi-Fi, right? N is the standard that released past maybe 18 the 802.11 AC, as Will said, we're talking about gigabit type speeds. So how do you sell that to a customer? Why would they want to buy an N today if in 9 months I've got a whole new platform?
Well, the question is whether they need to or not. And I think where you need to look in terms of technology trends is what's going on in the consumer space. Because it used to be that the enterprise drove a lot of technology out there. It's the consumer space that's driving up the bandwidth right now. In the video applications, it's BitTorrent, it's 11AC for AV communication with TVs and so on. I mean, right now, we have access points that go 900 megabits per second. So now you're looking at upgrading your Ethernet infrastructure from Cat 5 to higher to gigabit Ethernet. With 802.11ac, now you're above gigabit communication. The question is, do you need it? Does your enterprise need it? Does the hotel need it? Does the large public venue need it? Or do they actually need something less than that? The average user consumes about 5 megabits per second max. That'll go up with new video applications, but not everybody needs gigabit support. However, you do need to plan channels accordingly. And one of the most egregious design decisions that Apple ever made was taking the iPhone and releasing it as a 2.4 gigahertz only device. 3 available channels. It totally changed the user experience, especially in large public venues, because it's very difficult to do channel planning. So the IEEE learned from that, and 802.11ac, the new high-speed standard, will be 5 gigahertz only, so that we can move up into a band that gives us better channel planning capability and also allows us to have a quieter band than 2.4. Does everybody going to need it? No, they're not, but at least you'll know how to plan for it.
Still dealing from the client device to the radio network. You still have the transport network at the backside. So if you're trying to take a fire hose and shoot it through a pinhole, if you don't take care of your transport network back to the internet, and then everybody's going to suffer just like we did last night.
So that transport, what does that need to look like in the next generation? Is it fiber-based? Is that where we're going, just like with the DAS, that we've gotten to that stage? Yeah? Okay. So that said, is cellular offloading to Wi-Fi ready for prime time? Is it fair to ask AT&T first, Ron?
Yeah, we have been looking at Wi-Fi offload for cellular for quite a while. And I want to tell you, it depends on the type of the application. The degree of success of the offload depends on the type of the application. If you're talking about venues, large video venues, stadiums, yeah, it works. It works really well. If you are talking about Times Square, for example, lots of low mobility traffic, yeah, it works well. Now, you're talking about driving down the highway at 50 to 70 miles per hour, no, it's not going to work. And trust me, there are people who watch videos and do high-speed applications at 70 miles per hour. Trust me, there are. And if it's not the driver, it's going to be somebody in the vehicle. That's why in an environment like that, Wi-Fi offload is not going to work. I don't think we have figured out the mobility on Wi-Fi at high speed. And even on cellular, we are still trying to improve it. So Wi-Fi offload worked and worked well in some applications. Now with LTE, we're going to continue to see the need to improve both Wi-Fi and LTE to provide the bandwidth that we need. I mean, look 10 years ago, 300 kilobit per second or 1200 kilobit per second were sufficient, and we said what application is going to need megabit per second, and all of a sudden now we are consuming this bandwidth now, and who knows what's going to come down the pipe. Who knows what the next killer application is going to be. So we need to be ready.
Dennis, I'm going to ask you in 1 second, but I guess where I'm at is I'm trying to figure out how companies like Microsoft and Intel are not at the heart of this revolution, and how do we predict this stuff, right? And now that's rhetorical, that one, but it's overwhelming, I think, to be a business planner and trying to make a profitable business, trying to keep up with these trends. Dennis, if you want to expand a little bit on that.
Sure. From a hotspot operator perspective, offload's important. Savvy users, they're using Hulu and Facebook and some of these applications, FaceTime, that are more only work on Wi-Fi today. So, I'll do a lean. So, as I said, the offload is here today. So the users are types of application. So from that perspective, it's here. From the standpoint of seamless offload from a carrier's perspective, at least from my viewpoint, that's an evolution not only in 802.11u type standards, as a lot of those types of feature sets become available for a hotspot operator to be able to offer more seamless type offload and connection and access to whether it be a SIM-based type authentication or whatnot to that carrier. But at the same time, it still means providing connection managers and tools for those savvy users that can handle that offload themselves and be able to access venue-specific types of facilities.
Okay, so one of the phenomena, right, is the video growth. I teach a class, students, between 18 and 22 years old, and 90% of them download video. I know when I got my iPhone and I saw YouTube as an icon, I said, who the heck would do this? This is stupid. Right? That was my thinking, but yet the adoption rate of video and FaceTime is crushing our networks, and they're looking for any corner of the universe they can get at the signal they need, the strength, right? So what's Hotspot 2.0 going to do? Let me throw this one at Will first.
I think if we're evolving the network growth and really trying to evaluate the applications that are coming out, video being a very high chatty, lots of little packets flying back and forth, you're creating more interference opportunities with your cohorts who are also trying to clamor for that RF space, right? It's a shared spectrum. And driving voice frequencies over to Wi-Fi frequencies, and carriers like it's an SMS play, save my spectrum, right? Save it for the outside world where I can use it. I think designing our Wi-Fi networks with the intention of being able to support multifunction network plays, different applications, different services, different features, whether it's location-based services or not. You have to keep all of those in mind as you're developing your applications and your networks for your end user in mind.
Mike, can you comment on that? And if you can throw in a little bit on location-based services, does that impact the network?
It does, very significantly. First, with regard to problem deployments, I don't know if any of you have deployed DAS in a campus environment, but campuses generally are the petri dish for the worst environments you could possibly handle, because students walk in expecting everything they have at home plus more. So the BitTorrent, the gaming, more universities are relying wholly on Wi-Fi and no longer delivering Ethernet to the pillow. So you see everything possible. So from our perspective, you can't control end user behavior. What you have to do is make the network more intelligent so it can manage bandwidth. So do band steering, for example. So if a device is capable of operating at 5 gigahertz, you force it up to 5 gigahertz, even if the driver doesn't default there. Or you do airtime management, so that an 11B device, which is an older Wi-Fi device at very low speed, is unable to slow down the rest of the network. You prevent the other devices from going in legacy mode. So I think there's a lot that can be done on the Wi-Fi side to improve the user performance without trying to change their behavior.
Thank you. Dwayne, so do you see, I know American Tower's got about 250 DAS out there now. I know you have growth plans, and I believe Wi-Fi is being added to the mix more and more. When these integrators and contractors come in, are there companies that can talk to both and have a legitimate resume of experience building both DAS and Wi-Fi, or is that still different skill sets?
No, absolutely. I mean, they're definitely converging. Have to everything we talked about today. So, they're absolutely fine.
Okay. Do you see that, Dennis? Is there? I know that you've this is passing the microphone game.
Yeah, absolutely. I think it's also evident just based on members of the different broadband alliances and Wi-Fi alliances. It's not just Wi-Fi carriers or operators anymore. It's a combination of both, and they're working together to develop these standards.
My good friend Jim Parker was so good enough to give me some more statistics about AT&T's experience. Besides the 8,000% growth of the last 4 years, this year's Super Bowl required 1,500 antennas, 72 miles of cable, and had 500% growth over last year's Super Bowl in a venue that's smaller than the venue previously. 177 gigabits download, 215 upload. I mean, these numbers are staggering. Honey, talk to these public venues and how to attack.
Yeah, and every year it's more than the year before, way more. That's why one of the other interesting aspects of what we've seen in the Super Bowl is the uplink. The uplink, the capacity on the uplink is increasing every year after that. That's why lots of lessons learned from applications like that. And I want to tell you, we need, and I fully agree with Michael here, that we need to figure out as an industry a way to deal with ever-increasing bandwidth. That's why it's not going to stop. No applications, video applications. The reason for the increased uplink during the Super Bowl are so many people capturing the moment and sending live video from where they are to their families. We see it all the time. We've seen it last Super Bowl in Dallas. We've seen it this year. And this is a trend that is going to continue. That's why We need to figure out better ways to optimize the RF, not only for Wi-Fi, but for cellular technologies as well. And again, seamless access across all technologies is very important. It's going to be in our future very soon. I mean, in these stadiums, it's very challenging. And we put lots of RF on the ground, not only for Wi-Fi, but for cellular. And I want to tell you, truly, sometimes because we try to do that, sometimes we end up shooting ourselves in the foot by interference. So we need to figure out a way to allow all these technologies coexist peacefully with each other without significant interference to address this ever-growing bandwidth.
So, Hani, you mentioned they're sending videos and pictures to their families. How can you get my 18-year-old son to talk to me and look at me rather than through his device? I didn't think any of us have that answer, but...
FaceTime.
Yeah, FaceTime, okay.
we don't need in-person panels anymore.
Because when we're at the ball game, he's sending pictures and all that good stuff, and when we're sitting at home, he's receiving the pictures we're sending them, right? So it's certainly a little bit of a generational gap. Me, who had long hair in college, now I'm wondering, right? Okay, so coming back, Hotspot 2.0. All right, what are some of the challenges of maintaining the DAS and Wi-Fi system? Boingo's operating both in some venues, I believe, right? So how do you maintain both? Is it one NOC? Is it one maintenance crew? How does that get done?
Yeah, we look at it from the infrastructure basis that you can have a common infrastructure for both. Taking in mind the kinds of things that have been mentioned here in terms of future-proofing and using the single mode fibers and Cat 6s and appropriate cabling to support that. But yeah, from our perspective, we do manage it as a single system and have our NOC, whether it be for Wi-Fi customers and for our DAS customers, all managed out of the same thing. So it's venue specific, and then we have venue specific technicians to be able to support that.
And they're comfortable working on both types of systems, DAS and Wi-Fi, or is that still a challenge?
Well, it's a challenge because now you have to extend at least, for the most part, these things are plug and play, right? So if you have a device failure, you can send somebody out and say swap it out, and they know what they're, generally know what they're doing. But there's still a matter of educating your technicians to be able to support both types of networks. So that means that you have to have a little bit higher class of technician to be able to support both systems.
Thanks. I want to go back. Mike talked a little bit about the architecture and where Wi-Fi and DAS come together. But could you expand a little bit more? I mean, what are the commonalities? Antennas, yes. Access points, no. Fiber, yes. Where are we? If you could just kind of define it in the stage of development, what can ride together? The Ethernet backbone? Is that it? Yes, Mike. Sorry.
So no, you don't share antennas. That's the first thing. You need to do careful antenna placement to avoid interference because cellular will leak over into the 2.4 gigahertz band. You need to make sure Wi-Fi has appropriate filters on it and so on. So number one, you need to do appropriate antenna planning. The placement of devices is very different. DAS will cover a much larger area. An outdoor DAS antenna will cover a much larger area in a large public venue, for example. Whereas in Wi-Fi, what we're trying to do is create picocells. So we'll typically mount an access point under an area that's roughly 10 bleachers high by an area maybe twice as wide. And we'll have multiple small cells in that area. Thank you, Apple, because of 2.4 gigahertz coverage is really poor. If everything was 5 gigahertz, we'd do it differently. So the layout is different, the antenna positioning is different, but as I mentioned before, the backbone is the same. So you would have the access points connect to a switch that plugs into an expansion unit, a DAS expansion unit, and there you get your Ethernet connection. But the conduits can be shared, the fiber can be run at the same time, and so on.
Okay, so there's a way to balance that cost by doing the construction at the same time. what about MIMO? Are we pulling 4 cables, 6 cables now? And is that all going to happen at the same time if DAS and Wi-Fi are both MIMO? Where are we as a state of an industry here? And anybody can take this one, because I'm actually a little confused on this part.
I mean, the answer is yes. You're going to pull it all. I mean, if you need MIMO, that's what you're going to pull.
And then that's the trade-off, right? I mean, we're basically talking close to double for MIMO in terms of construction? Yep.
Right.
Right. So building 2 MIMO systems, right? So
Well, yeah. And you, like he was saying, that basically we're getting closer to where we're getting further out on the edge where we can integrate Wi-Fi into the DAS. But right now, to be for most systems, we're talking really at the fiber aggregation area is really where you're going to see most of it.
okay, getting a little catty here. What's the debate inside of AT&T, licensed versus unlicensed?
Well,
What groups are vehemently opposed?
Well, I was afraid that you were going to ask me this question.
I had to do
So, look, there is no question that Wi-Fi and cellular evolved from completely different heritages. That's why they came up from completely different backgrounds. That's why, if you try to do the integration today, it is pretty tough. I mean, it's pretty tough. And if you try to do it today, I fully agree with Michael that the best way is actually to try to use the DAS for backhaul. Now, the fact of the matter is small cells are evolving. Integration of Wi-Fi in small cells is going to be part of our reality soon. So we need to figure out how to optimize the use of antennas. I mean, small cells need to be small. So if I put a small cell that is smaller than your briefcase and need to put 6 antennas around it, nobody will install it. Nobody will agree to put it. No municipality that will agree to put this ugly thing on a pole. So I want to tell you, evolved from completely 2 different backgrounds, different heritages. I agree that there might be some compromises by separation of antennas and separation of radios from the Wi-Fi AP. But guess what? The cellular industry figured this out a long time ago. We put the radios and put antennas on the top of the tower, and sometimes we put the base station and the processing all the way in the CL. So why is it the Wi-Fi technology can't figure this out? Now, I agree that there are completely different cost structures, but on the other hand, small cell has to deal with this because the expectation that small cells will be around the same price point as a Wi-Fi AP. So moving forward, this is something we need to solve. We need to figure out how to coexist peacefully, especially for small cells. I mean, I agree, different bands, different design guidelines, different MIMO techniques, different. All of these are good points. But on the other hand, I mean, there is no escape from trying to figure out how all these technologies can coexist peacefully.
Okay. T-Mobile's perspective, I'm going to guess unlicensed wasn't as big a battle given the Wi-Fi and access for voice, but what goes on between the licensed and unlicensed camps?
Primarily licensed, right? Wi-Fi calling is the optimal solution to provide indoor coverage when you can't get good macro coverage, bottom line. There's tremendous quality of service challenges, and you need a pretty good, solid infrastructure and heavily designed and engineered infrastructure in a Wi-Fi network to be able to support the quality of service. Voice is very sensitive to packet loss, whereas internet browsing is very friendly to packet loss. So you got to take a lot of engineering considerations in mind with the Wi-Fi network.
Okay. All right, well, that said, I think we have maybe about 10 minutes. Now, if nobody gets up, I'm going to sing a song. So if you have questions, come on up. Nobody bites. I know you got them. Okay. Old MacDonald. No. Okay. Right, but then we'll go back and ask some more questions prepared previously. From a, I'm trying to look out, okay, and I think you guys have talked to it, and just going across the lane here, how far out can you look? Let's quantify it. Start with Dennis. When you look at your network architecture, How far out is reasonable to really plan to, and where are you in the state of mind knowing maybe it's only 1 year, 2 year, 3?
Well, I'd say from our perspective, we're looking at planning over the next few years as the Hotspot 2.0, 802.11u systems become available. And it's going to be a migration path to that. So as any venues, or we're the hotspot operator to major venues to start that implementation really in the next year. But then over the next couple of years to work with places where we have an aggregator relationship to get them up to speed. Because it's the future in terms of offload, and be able to offer those types of services that 802.11u provides to our customers, which will be the carriers, which will also be our direct ad hoc paying customers, and as well as the venue operators themselves, because just handing off everything to the carrier may eliminate that capability for the venue operator to be able to offer some services like we talked about with location-based type services, or specific targeted advertising for some of their concessions and whatnot, say for example in an airport. So that's really our plan, is over the next few years, is looking at that integration.
I'd say we're probably on a 2-year forecast. Looking out 2 years is really about as far as we can go, because the network is changing so rapidly, and the infrastructure and applications and user demands are so rapidly growing. 2 years is about as safe as we're willing to look.
We try to say 3 years because that's what the carriers kind of give us forecast-wise, is what they're looking at from both the DAS and kind of a Wi-Fi perspective. But we have to balance that obviously with what the landlords may be asking for as well. I mean, so we're been primarily carrier offload for a long time, but now we've got something else to balance against going forward, because Wi-Fi is a big ask there.
Ronnie?
Forecasting beyond 2 years is kind of tough. Forecast is a tricky business, and we normally do a 2-year planning cycle for all technologies, but you need to refine this almost on a quarterly basis, and sometimes you can see 25% overshoot or undershoot from quarter to another. So anything beyond that is kind of tough.
Mike, similar?
No, I'd say we have a longer-term outlook, looking at 5 years. If you're dependent on creating custom silicon, you have to look out farther. You have to see where trends are going. One example is in the area of network security. RSA is not going to be long. There are issues now in the government with using RSA, so they're looking beyond that to the next generation, which is called Suite B. So we have to plan for that, do our implementation, work with different vendors on the availability of that. It's an initiative driven by the NSA. They have the money, in order to do it, but it's going to take 3, 4, 5 years for this to get implemented. So I'd say our horizon, looking at antenna design, looking at next IEEE standards that are coming, network security, BYOD security, it's got a 5-year horizon.
So it sounds like the operators are under a lot more pressure. Yeah. Okay. Again, one more try at questions. Okay. Well, that said, we have one.
Question there.
Do we have one? There we go. You'll get the award after. I'll see you in the hallway. Thank you.
Ewan with Harris Communications. I just need a good working definition of the product set and how you're defining small cell.
Good question. Good question. Ron, you want to give it a first shot? I see shaking heads.
Well,
I love this evolution.
Well, this is actually a very good question, because small cell has lots of definitions out there, and DAS is considered or can be easily classified under the small cell umbrella. That's why it's kind of a loose definition for now. Now, I'll talk about this from an AT&T perspective. From an AT&T perspective, our definition of a small cell is a small cell that, or a brief size case device that can support cellular technologies and Wi-Fi in a very small footprint. And we are talking about integration of antennas, radios, and baseband units in one device. So traditionally, you see that those, something very similar to the Wi-Fi AP that you know of today, but it is supports cellular technologies at the same time. We are open for multiple antennas, but we hope for integrated antennas in the near future. So it's, again, a briefcase size cell that supports cellular technologies and Wi-Fi at the same time. Two cables come out of it, a backhaul cable and a power cable. That's it. I don't know if this is what you're looking for or you're looking for something else.
Okay, you ask one guy, you get one answer. Anybody else want to define differently? Or same? I'm not...
Our interpretation of a small cell is basically very similar to like a Wi-Fi sized box, dealing with coverage area and number of users that can be supported, primarily with the voice network, not Wi-Fi combined boxes. So keeping the technologies in separate architectures. Wi-Fi architecture is really designed to be a distributed processing architecture, whereas cellular technologies tend to be more centralized. So some small indoor RF devices, IP access, etc., can be hooked up to passive DAS if it's a coverage solution versus a capacity solution. So there's a lot of blending in the deployments of small cell hardware that really blurs the lines and makes it opportunities for everybody, I think.
Great. Anybody else want to touch on that? No? Okay. All right, well then we're just about done, but before we conclude, I'd just like to pay some respects. At 2:15 we have a panel on public safety and DAS. We've got some really strong experts, but there's one guy missing. Good friend, Jack Daniel, to the industry and to many of you out there, passed away in the past couple of months, so I'd just like to acknowledge Jack's passing and all the good things he did for our industry and public safety. But the next panel is going to be the keynote, the carrier perspective. Ian Gillott, who I keep getting his IGR stuff, so I'd be happy to meet him shortly. And Scott Simone from Verizon Wireless, and Lorna Slott from AT&T ASG. So I think we have a few minutes to break, and then we'll be getting started shortly.